divided by probability of A into probability of R given A plus probability of B into probability of R given B, right? So just substitute the values now. So probability of B is 1 by 2, probability of R given B is 5 by 9. So divided by probability of A is 1 by 2, 3 by 5 plus 1 by 2, 5 by 9. So altogether 25 by 52. Is it clear? So similarly, the next example, the first box contains 2 black, 3 red, 1 white balls, and the second box contains 1 black, 1 red, 2 white balls, and the third box contains 5 black, 3 red, and 4 white balls. Here, in the previous example, only 2 bags. Here, whereas in this example, we have 3 boxes, 3 different types of colors of balls, right? So, how this box is selected randomly. From it, same, red ball randomly drawn. If the ball is red, find the probability that from the second box. Here, in box 1, box 2, box 3, right? So, we have 3 boxes. So, in that, black, red, white, black, red, white, black, red, white. So, out of 3 boxes, right? So, in the box 2, so in this we need to select only a red ball, right? So, that is a problem. So, now, here, let x, y, z be the first, second and third boxes. P of x equals to assumption 1 by 3, P of y equals to 1 by 3, P of z equals to 1 by 3. So, previously we assumed only 2 bags, then 1 by 2, 1 by 2. Here 3 boxes, 1 by 3, 1 by 3, 1 by 3, right? So, let R be the event of drawing red balls from the box, right? Then, so probability of R given x, that is total number of box x is 6 balls, out of red is 3. Then probability of R given y equals to 1 by 4, probability of R given z is 3 by 12. So, here second box, right? Then what is the formula? Second box in that red ball. Then probability of y given R, that equals to probability of y into probability of R given y divided by probability of x into probability of R given x plus probability y into probability of R given y plus probability of z into probability of R given z. So, that equals to 1 by 4. So, this is a problem. Now, coming to third problem. In the previous 2 problems, P of A and P of B values we need to assume if not given. So, whereas in this problem directly P of A and P of B values are directly given, right? So, here the case is, suppose 5 men out of 100 and 25 women out of 10,000 were are color blind. Okay, assume male and female are equal in number, directly given. That means just P of M, male 1 by 2 and female or else women 1 by 2. So, P of B by M. So, B value is 5 out of 100. So, B by W 25 out of 10,000. Then just substitute the value, we get 1, right? So, similarly next problem. In a bolt factory machines, A, B, C manufacturers 20%, 30%, 50%. The previous 3 problems, okay, so we already assumed, right? In this problem, some 20%, 30%, 50% values are given. That means P of A equals to 20%, P of B equals to 30%, P of C equals to 50%. Of total of their outputs, 6%, 3% and 2% are defectives, right? A bolt is drawn at random and found to be defective. Find the probability that manufactured from machine A, machine B and machine C, right? So, let us see machine A. Let P of A, P of B, P of C be the probabilities of event that the bolts are manufactured by the machines A, B, C respectively. Then P of A is 20% is given, right? 20 by 100, that equals to 1 by 5. P of B is 30% is given, right? 30 by 100, 3 by 10. P of C is 50%, 50 by 100, 1 by 2, right? Let D denote that the bolt is defective. These values are also given, 6%, 3% and 2%. That means D by A, D by B, D by C, right? So, for example, in machine A, so machine A means P of A by D. Then P of D given A into probability of A divided by probability of D given A into probability of A plus probability of D given B into probability of B plus probability of D given C into probability of C, that equals to 12 by 31. Similarly, in the second machine, probability of B given D equals to 9 by 31, probability of C given D equals to 10 by 31. So this is about probabilities, right? In this we did theorems of probability, additional theorem problems for mutual and non-mutual, and base theorem problems, compulsory problem. So 50% of concept is completed in the unit number 2.